Hello everyone, and welcome back to our continuing discussion on Chapter 2 over linear equations in one variable. We're going to change it around a little bit this time, and now we're going to go from equations to inequalities in one variable. Now, this actually really isn't a whole lot different than what we've been working with. The largest difference is we're not dealing with equal anymore. We're actually dealing with inequalities, which is our little greater thans and less than signs. So some general inequalities here. Y minus 4 is less than 18. Initially we had this as like equal. Now we're saying instead of saying that y minus 4 is 18, we're saying that y minus 4 is going to be less than 18. What that does is it changes it from being a single answer to really almost any answer as long as it fulfills the condition y minus 4 is less than 18. And of course, this does not have to be, set to a single variable. You can have multiple variables, x, y, z in this case. What matters is the equality is no longer, the relationship is no longer an equality. It's a relationship. In this case, a less than here. This is a greater than or equal to. So in other words, this could equal that, or this could be greater than this. The only thing this can't tell us this does tell us, is this will never be less than this. Obviously, if that happens, that's wrong. We've got a problem. So in many ways, just like linear equations, it is related to, instead of an equals, we have greater than or equal to, or less than, or even less than or equal to. So it's almost exactly like a linear equation. It's just instead it's no longer an equal sign, it's a little less than or greater than sign. So we're going from this set thing, we know this is this, to this is related to this with conditions. Now, a lot of the exact same properties hold with inequalities as they do equations. The biggest being, of course, addition and subtraction. If we know that A is less than B, whatever they are, then if we add C to both sides, then this will stay true. Or if we subtract C from both sides, this is still true. Again, just like with equalities, the biggest difference is that whatever you do to the left, you have to do to the right. That way it keeps it equal. Now that means for the less than, it's also the same for the greater than. There's no difference at all, just the way it looks. All this says is now the left side's bigger than the right side, where before it was the left side was smaller than the right side. So a little quick example here we'll look at is x minus 7 is less than negative 12. Well, given our initial relation, we want x to be all by itself. So we solve using our initial steps just like before. So we just add 7 to both sides, like so. So this destroys the 7 here and here, and we're left with x being less than negative 5. Now, if this could have been an equal sign, and this whole thing would have been just, these steps would not have changed. Only thing different here is this sign here being a less than. Another little more evolved equation is this one right here, where we start with 14 plus 2x greater than 3x, and then change it by moving x to one side, all the x's to one side. In this case, I move this x to the right instead of to the left, just because the 3x is bigger, so I know that I can subtract both sides and this will stay positive. It's just neater this way. So I subtract 2x from both sides, and we just get 14 is greater than or equal to x. And of course, you can also read this one way and then read it the other way, but you have to be careful when rewriting the final step that you put the x when you put the x on the left. Doing so flips the relation. So otherwise, right here, we're saying 14 is greater than or equal to x. So if you read it the other direction, x is less than 14. So we have to make sure that we use the right relationship sign to make sure that these two stay equivalent. Now this comes to another part that's going to be a very big difference with inequalities compared to equations. With equations, for multiplication and division, it stays almost exactly the same. If a is less than b, we can just multiply both sides by c or divide both sides by c, and the relation still stays the same as long as c is greater than 0. Now, it used to be as long as c wasn't 0, not equal to 0. In this case, we're saying greater than, which unfortunately means that if c is less than 0, it changes it. And what happens is, when c is less than 0, it flips. So if you multiply or divide by a negative number, which is what c less than 0 means, if c is a negative number, the relationship flips. It goes from a less than to a greater than. Now, it may not make a whole lot of sense, so we're going to look at this with a very simple example. So let's look at -2 less than 5. No real, we're not looking at variables here, we're just stating -2 is less than 5. That is true, and you can look at it on a number line. -2 is less than 5. So if you multiply both sides by 8, which is greater than 0, what you get is -16 less than 40. That is still true. So that part holds as long as since we multiply both sides by a +8, the relation never changed. So let's look at it again, but only this time let's do -8 to both sides. So -2 times a -8 is a +16, and 5 times -8 is a -40. So we get that 16 is less than -40? Now, we know that's not right. We know 16 is larger than -40. And this is why you have to flip the sign when multiplying by a negative. Yeah, so that's where you always have to be. That's the biggest thing that people need to remember, and when they're working with inequalities, if you multiply or divide by negative, flip the relation. So now we're going to look at another one, only this time we're actually going to use a variable again. So again, we go through the same initial steps we always do. Get rid of any fractions or decimals, which we don't have any. Great. Second step is simplify both sides individually. Well, in this case, the right side is fine, 7 minus x. So we need to distribute the -3, like so. And this, of course, then simplifies to a -10. And again, I am going to simplify both sides by moving this -x over and moving this -10 over here. So I will add 10 to both sides, killing the 10s. I will add x to both sides, destroying these x's, which gives me -2x is greater than or equal to 17. So now my next step is to divide by a -2. And again, we're dividing by a negative, so we're flipping the sign. So now we have this side is less than or equal to this side. And again, -2's cancel out here, so we're left with a final answer of x is less than or equal to -8.5. Now, another thing you can look at, and we'll see, is this thing called three-part linear inequalities, in which case what we're saying is, with a and b being real numbers, and a is less than b, x is between these numbers. That's what it says. A is less than x, less than b, or a is less than or equal to x, less than or equal to b. What this is saying is x, this number x, whatever it is between a and b. And that's why we always make sure a is always less than or b, because we're looking at it as if it's a number line. We're going from a smaller number to a bigger number to an even bigger number. Now, how do you solve these? Especially when right here where we have x in the middle with a plus 2. Well, the easiest way to do it is we treat it just like we do our other inequalities and our other equations, only we're doing it as if like within a single line. We treat this as 1. 3 is less than or equal to x plus 2. And then we also treat this one as a separate. X plus 2 is less than 8. And we got to treat that as if it was the same thing. So, easiest thing to do here is to just, like we would with any equation, subtract 2 from both sides. Well, since in this case, because it's a three-parter, 1, 2, 3, we're going to subtract 2 from all 3 sides. So we just subtract 3 from 2 here. We subtract 2 from the middle, which these will destroy each other. And we subtract 2 from the right. And that gives us our final, where x is somewhere between 1 and 6. And you can try this out. If you plug in, say, the number 3, you'll get 3 is less than or equal to 5. Less than 5, less than 8. That's true. Now, if we go to a number, say 7, we get 3 is less than 9, which is true, but 9 is not less than 8, so that part makes it false. So as long as x is between 1 and 6, this part stays true. Alright, now let's get to another more involved example again. So we're going to do the same thing, just like we do. We're going to treat this as one, and we treat this as another. So whatever we do to this one, we have to do to both. So whatever we do to the middle, we have to do to the outsides as well. So the first thing we're going to do is we add 1 to all sides. So we add 1 here, add 1 to the middle, and add 1 to the outsides. That'll destroy these. And that leaves us with -1 less than or equal to -3x less than or equal to 6. So now we want x to be all by itself, so we're going to divide by -3. And again, this is negative. We got to be careful. So when we divide, we flip both of them. You'll never flip one and not the other. It will always be both. So we divide both sides by all 3 sides by -3, and this gives us that 1/3 is greater than or equal to x greater than or equal to -2. While this now is technically true, it's not the way you're supposed to do it. It should always be read smallest to largest. And the easiest way to do that is we essentially write this backwards. So we go -2 is less than or equal to x, less than or equal to 1/3. So we're going from a smaller number to a number that's bigger to another number that's bigger. So it's like reading this line backwards. We're reading it from the right to the left. Again, thank you for listening to the lessons. Here are again our links to all the sections if you wish to re-look at all of our examples and the individual properties. Make sure if you have any questions or comments on review problems to post in the video or on the site. And I will see everybody in class next time.